Hello and welcome to the deep dive on Amazon Virtual Private Cloud webinar. My name is Kevin Miller. I'll be your presenter for today. Here we have with us is Mark Stalzer, who's a Principal Product Manager from AWS. Mark is going to be our Q&A moderator today. Before we begin, I'd like to walk the audience through a few items. On your screen, you can see a Q&A panel. Please submit your questions at any time during this webinar. Mark will answer as many as time allows in the Q&A panel while I'm presenting. And towards the end of the webinar, there's going to be a live Q&A session, and I will address some of the questions as well. Lastly, this webinar is being recorded. We'll share the recording and the presentation slides via email a few days after this webinar concludes. So before we begin, I'd like to note that we have a few related presentations and online videos, and these are all on the YouTube website. You can search for these on YouTube and read about or read and see videos that deep dive on a few additional aspects of virtual private cloud as shown here. So I want to note that today's presentation is going to be a bit of an expert mode on VPC. So we are going to deep dive into some of the corners of VPC and configuration for some advanced networking topologies. So again, please feel free to ask questions of Mark throughout the presentation, but we're going to be deep diving here as we go. Now today I'm going to talk about four primary topics. The first will be routing and private connections. The second will be on our VPC Peering feature. The third will be enhanced networking. And the fourth will be a conversation about, we'll talk about a service that we launched just over a week ago, and that is the VPC Endpoints for Amazon S3. So before I begin, I want to briefly review some of the terminology that you may see throughout the day. When EC2 launched, initially we launched with what we call our classic networking experience. And this is an experience that is fairly simple to get started. Every instance in our classic environment has internet connectivity, as well as private and public IP addresses that are automatically assigned by AWS. And to control inbound access to instances, customers are able to use inbound security groups to allow access to certain ports and IP addresses. Now on the right-hand side, when we launched our virtual private cloud service in 2009 rather, we've begun to add a series of advanced virtual networking services as part of our EC2 networking service. And so with VPC, customers are able to take advantage of a number of advanced capabilities, including our elastic network interfaces, multiple IP addresses, routing table support, support for filtering traffic both inbound and outbound, as well as network ACLs, which provides a separation of function capability between server administrators and underlying infrastructure network administrators. As well as private connectivity through IPsec connectivity or our Direct Connect service, as well as enhanced networking, which I'll speak to in a few minutes. And VPC is an area where we are continuing to invest and deliver new capabilities based on feedback from our customers. Now, a few years ago, we built a capability that merges the two of these environments. And so the idea is that new accounts to AWS are given a default VPC. This allows customers to get started with our classic experience using the very simple experience of launching instances with internet connectivity and then having automatically assigned public and private IP addresses. But with default VPC, you can get started with that simple capability and then add VPC features as you need based on the individual workload or application. And so all accounts that have been created after December 2013 support VPC only and have a default VPC to get this ideal experience. So if you want to confirm and double check that your account supports default VPC, it's simple to do through the AWS CLI, and I'm showing on the screen here how you can do that. Throughout the day, I'll be showing a number of CLI commands. In fact, almost everything that I talk about today, I'm going to provide the commands that you can use to use the feature or confirm use of the feature. So in this case, when we use the describe account attributes command line tool, we can see that we have a default VPC. That's the VPC ID that you see there, and the supported platforms value is set, it shows VPC, which indicates it's a VPC-only account. So now I'm going to begin talking about routing and private connections. And so one of the benefits of virtual private cloud is the ability to use routing and private connectivity to implement a hybrid architecture where parts of your application may run in a corporate data center or an off-premises location, and other parts run in VPC. And we see customers running in a variety of modes, some modes where most of the application runs in a VPC, but may use resources from a remote data center, and others where the balance is different. So if we start from resources in a home data center or off-site, off-premises location, we'll then create a VPC so that we can begin to make use of VPC and EC2 to host instances. And so again, I'm showing the command line tools that you can use here at the bottom. So this allows us to simply create a VPC, we assign some IP address space, and then we're able to create 2 subnets in different availability zones within our VPC. Next, we're going to use our VPN capability to create IPsec, secure IPsec connectivity that will allow private IP communication between the resources we have in our corporate data center and our VPC instances, our instances running in the VPC. So here's an example where I create a VPN gateway and attach it to my VPC. And then I specify the IP address of my VPN device, whether it's a software or hardware VPN router. I specify the IP address and then wire those two together to create a private connectivity. Next, I'm going to just launch some instances, and this would be these could be either Linux or Windows or other even custom images that are instances that are based on a custom image that I've created. But in this case, I'll just launch a few instances. I can specify that I want to run 3 instances in each of my 2 subnets, so I'll end up with 6 instances that are split across my 2 availability zones. And now at this point, I will have the ability to communicate via my VPN connection. I'll be able to communicate using the private IP addresses, so in this case, using the 10.10 IP addresses to the applications or resources that are hosted in my corporate data center. Now, next I'm going to talk about using AWS Direct Connect. So Direct Connect, like our VPN service, provides the ability to have private connectivity between these 2 facilities, whether it's a co-location or a home data center. And in fact, Direct Connect has APIs as well that allow you to create connections and then attach them to your VPC. So here's an example where I'm creating a connection in a particular facility, in a particular Direct Connect location, and I'm creating a 1 gigabit per second connection. Now, obviously, Direct Connect is a service that involves physical cross-connects of fiber between a router that you may maintain and the AWS router, or a connectivity that's provided through an Amazon partner from the Direct Connect location to your office location. So although this cannot be completely accomplished with APIs, these APIs are used to create the configuration at the AWS side, and then subsequent to this, the steps can be taken to complete that connection on your network. So again, here's an example where I've created the connection and attached it to my VPC. And once this is complete now, I'm able to use this Direct Connect connection to transfer data using private IPs between the 2 areas, the VPC and the on-premises location. Now, in the VPC, each VPC has a router, a single router, and I should note that the router is a highly available, high-capacity router. There's no need to worry about redundancy of this router, as that is all managed by AWS. This router has routing tables, and each VPC has a default routing table, created when the VPC is created. And unless otherwise configured, that routing table applies to all subnets. So routing tables are associated with subnets, and you can create custom routing tables, which I'll show in a few minutes. But in this case, I'm going to create a route, a default route in this routing table, and I'm simply going to steer the default towards my VPN gateway, that being the gateway that connects to my IPsec tunnel or my direct connect connection. And so this routing table configuration will steer any traffic that's not going somewhere else in the VPC or that's not within that 10.10 address range will be steered towards the private connections. So I want to briefly talk about best practices for remote connectivity. Customers often ask me, what sort of availability, what do I need to do to build the remote connectivity to achieve my availability requirements? And so what we see as often a initial configuration is a VPN connection from the corporate site, from an off-premises location to AWS using the to the two VPN endpoints that exist in different availability zones. So a single IPsec VPN connection from AWS consists of two tunnels that land in different availability zones. And so this provides good availability. If there was any interruption in the VPN equipment on the AWS infrastructure, with this traffic could be automatically switched to the other tunnel. And we do recommend the use of BGP across these tunnels. BGP in this case is not, some people think of BGP as being an internet construct. In this case, BGP is just used for liveness signaling and failure detection for these two tunnels. So using BGP, we can shift traffic back and forth across the two tunnels if there's any sort of interruption on the intermediate path. And this provides good availability. The next step that customers often take, though, will be to establish a pair of VPN, well, rather two VPN connections, which will end up being 4 IPsec tunnels with BGP. And this configuration allows you to provide resiliency against a failure of the VPN devices either at the data center side or at the VPC side. So this does provide better availability than the previous model that I mentioned. And then finally, for customers that have very high availability requirements, we do recommend investigating and using Direct Connect to provide those connections from redundant devices in your facility to redundant Direct Connect routers. Each of our Direct Connect locations provides 2 physically separate endpoints to terminate connections to. And in some regions around the world, we now have multiple geographically isolated Direct Connect locations to provide even greater assurance and diversity of connectivity from an off-premises location into AWS. All right, so we've talked a bit about private connectivity. I now want to talk about a model where you have both public and private connectivity in a single VPC, which we have plenty of customers using today. And so the way this is done with VPC is what we call the Internet Gateway. The Internet Gateway, again, is a high-capacity, highly available construct, so you don't need to worry about its availability. And the Internet Gateway is attached to a VPC. And then what I'm doing here is I'm showing how I'll change my routing table. So what I'm going to do here is shift my private traffic to use the VPN gateway and change my default route to instead to go towards the Internet Gateway. So this would mean that any traffic that's headed to my corporate data center will use the private connections, and then any other traffic that's not going there or to my VPC will instead be sent to the Internet through the Internet Gateway. Now, we have an additional feature of our VPN gateway that some customers find helpful, and specifically the route propagation feature can be turned on. What this does is it eliminates the need for you to manually update the routes when you add routes on your corporate network, on the network that's being connected from through the VPN or Direct Connect service. So with this feature, anytime a route is added and begins to be advertised through BGP to the Amazon routers, we will automatically propagate that route into your VPC routing table so the traffic will be steered towards your network, towards your private network. And then I mentioned as well earlier that we do support, with VPC, we support subnets, secondary routing tables that can be associated with subnets. And so by default, all subnets will be associated with the default routing table. In this case, I'm going to create a third subnet, the .3 subnet, and I'm going to create and associate a new routing table with that subnet. And so what I've done here then is update that routing table and create a route that goes only to the internet gateway. So once I've done this, any instances in this .3 subnet will have connectivity only directly to the internet. These instances in this subnet will not be able to reach through my private connection back to my corporate data center. Now, some customers have also looked at establishing private connectivity between VPCs, and we can use this secondary routing table feature to affect that kind of configuration. In this case, what I'm showing is I have two VPCs, and in those VPCs, I have software-based VPN appliances. And these software VPN appliances are placed into subnets that have secondary routing tables. And what I do is I've created routes in the other subnets, in the primary subnets, that direct traffic to the peer VPC through the VPN instance, and I specify that by the instance ID. And this is going to allow me to create private connectivity between VPCs using software VPN appliances. And so I'm showing here that the VPN traffic would be from the VPN between these two VPN appliances, and the instances in these in the subnets on the top half would be the instances that would be able to use that VPN to communicate with instances in the paired subnet on the other VPC. Another feature that is similar, or another configuration that is similar, is a configuration where I'd have a custom NAT or firewall appliance that I want to have sit between instances in my VPC and the internet at large. And again, here what I've done is I've created a secondary routing table, and in the secondary routing table for my .3 subnet, I'm just going to direct all traffic from that subnet straight out to the internet. But then I'm configuring traffic for instances in the other subnet, the .1 subnet, to use the NAT firewall appliance, and then I can do anything I want on that appliance in terms of firewalling, security policies, natting, and other types of security controls. Okay, next I'm going to shift gears and talk about our VPC Peering feature. So VPC Peering is a capability that allows, similar to what I showed on the prior screen, where we have customers had configured a software VPN to connect two VPCs together. VPC Peering now provides a mechanism for doing that does not require configuration of a VPN software appliance. So VPC Peering provides VPC-to-VPC connectivity using private IP addresses. And one of the common use cases we see for this is what we call a shared services VPC. And simply put, that is a VPC such as VPC-A that might provide common services for your enterprise. That would include things like authentication or directory, monitoring, logging, remote administration, or security scanning. So these are common sorts of common services that customers configure. And then that VPC, in this case VPC-A, could then be peered with application or business unit specific VPCs for purposes of providing that common functionality. Another use case that we see customers using VPC peering to provide is infrastructure zoning, where I might have, for example, a development VPC, a separate one for test, and a separate for prod. And in fact, one of the things customers do with this is they actually use this to configure identical address spaces between the VPCs so that applications can be tested in a completely identical environment and then just use bastion servers in a common VPC to access the different dev test or prod VPCs for purposes of administration. But this allows you to have a complete replica of the virtual network underlying your applications and confirm that, that everything will work as intended. So the way that we configure VPC peering is to, in this case, have two VPCs, as I've shown before. We then create VPC peering connections. And when I do that, I just have to specify both the local and peer VPC that I want to connect together. And in this case, I'm showing that I'm assuming here that, that these are both operating in the same account, that both VPC A and B are owned by the same AWS account. So I create the VPC peering connection. I then need to accept it. So every VPC peering connection does need to be accepted by the peer VPC before we establish any connectivity. So this provides a complete two-way handshake before connecting the two VPCs. And then once I've connected them, I can create routes in my routing table. In this case, I'm just showing this in my default routing table that directs traffic to the peer VPC through that peering connection. So again, you have complete control over the destination of traffic through the VPC routing table. Now, VPC peering can also be used across accounts. And so within the same region, if you're interested in creating, connecting two VPCs together, again, for private IP connectivity, you can do so. The only difference from what I've previously shown is that you do need to specify the owner account ID, the AWS account ID for the peer when you're creating one across accounts. And then, of course, the peer owner account needs to be the one that issues the accept configuration command. So again, both accounts have to do a handshake for the respective VPCs for that peer to be established. A few other things to think about when you're setting up VPC peering. First is that when you're to configure security groups in the respective VPCs, you'll need to use IP addresses, IP prefixes, to allow access from instances in the peer VPC to access resources in the other VPC. Second, right now we don't support what we call a transit capability. So, for example, if you have three VPCs, we recommend that you peer all three of them sort of pairwise with each other if all three need pairwise access. If you have three, we don't support functionality where one VPC sends traffic to a second, which then sends it to a third. And then finally, we do need to ensure that the VPC address ranges don't overlap. And in fact, the system does enforce that. But when thinking about planning VPCs, if you are planning to create several, it's important to think about the IP address allocation to ensure that the ranges don't overlap. Now, additionally, in the prior section, we talked about the use of a NAT or firewall device to reach the internet. Some customers actually also use this configuration to mediate traffic that goes across the peering connection, into another VPC. So similar to what we did before, in this case, we'll create a second subnet with a second routing table that will run a NAT or firewall instance in that subnet. And then the next hop, the destination for traffic coming out of that .3 subnet on the left will be my VPC peer. Previously, we talked about this in the case where it was the internet gateway. In this case, it would be directed towards the VPC peer. And again, this would allow me to have a NAT or firewall device that sits on the path between traffic that's leaving towards the other VPC. Okay, I'm now going to shift gears and talk about enhanced networking. So one of the significant drivers for latency in applications, particularly applications that have a high request response rate, is the aggregate number of packets per second that an instance can deliver onto the network. And so, and this is the request response pattern is something we see for a lot of applications that customers run on EC2. For example, applications that do web services calls or applications that access a database to do a query response will commonly be following this pattern of a high rate of request response. And so it's important to understand what the packet rate onto the network is, and as the packet rate goes up, latency can increase. And so To show the benefit of enhanced networking, I'm first going to talk about sort of the way that networking from an instance out to the physical network worked prior to enhanced networking. And so here's what it looked like. In this case, I have an instance. I can have one or more elastic network interfaces. That's what's shown here as virtual NICs. And any traffic that's sent or received from that instance is sent through the virtualization layer, where it's then transmitted onto a physical NIC and out to the network at large. What enhanced networking does is provides a capability where traffic is sent from the instance directly through hardware to what's known as a virtual function on the physical NIC. And this allows this network traffic to bypass the virtualization layer and directly access this virtual function to be transmitted out to the network. Now, what this requires in order to function is it requires a specific driver be installed in the instance that the driver then knows how to access the virtual function. And then further, it's going to require configuration of EC2 to activate and provide that virtual function for the instance. And the industry term for this capability is single root I/O virtualization, SRIOV, but simply put, we call it enhanced networking. And so we've done some. This is data from a sort of a routine, a simple test that we ran, and across the bottom we show percentiles. TP0 would be the 0th percentile. That would be the minimum. TP100 would be the maximum. And what we show is the latency of traffic between instances using both our regular virtualization, network virtualization, and the enhanced network virtualization. And so what you see is that particularly as instances reach a higher number of packets per second, that would be more to the right, the latency on our regular networking network virtualization stack goes up, while in the case of enhanced networking, it goes up by just a hair more than it does in the minimum case on the left. So we definitely see latency improvements in request response type payloads when using enhanced networking. So again, this is a function that we recommend almost all customers use, but particularly customers that have a high packet rate and a request response type application. So enhanced networking is actually already enabled for all of the latest Amazon Linux images, as well as the images Amazon provides for Windows Server 2012 R2. So in these cases, there's nothing to configure. You just need to launch enhanced networking on supported hardware, which I'll discuss in a moment. You can confirm, though, that it's on. In Linux, you can run this ethtool command, and if you see the driver being this IXGBEVF, then you know that enhanced networking is turned on. Similarly, on Windows, the network adapter will show as an Intel 82599 virtual function, and that again confirms that enhanced networking is turned on. So we support enhanced networking across 23 different instance types, including in our C3, C4, I2, D2, and R3 instance families. So as you can tell, this is a large and growing list of instance families that support enhanced networking. You do need to use the HVM virtualization type. So when launching an instance, you can launch either as paravirtualized PV or HVM. And for enhanced networking, HVM is required. Again, you require certain versions of the base operating systems with the appropriate drivers. And again, this is all pre-configured in the very latest Amazon Linux AMIs and Windows AMIs, but can be enabled in older AMIs as well. So to confirm that you're launching an HVM AMI, you can just typically look at the image, the name in the image. And to confirm whether or not we have configured the instance for enhanced networking, you can use the describe instance attribute command or API. And you can see from the output here that enhanced networking is not, in fact, turned on. So this is a case of an older Linux AMI that I'm just going to update. to install enhanced networking and show how that works. So I first do an OS update. I then reboot the instance. In the case of Windows, I can download and then install this particular driver, the Intel 82599 virtual function driver. And this is how I actually install that driver on my Windows image. And in the case of an EBS-backed instance, at this point, I would, Windows instance, for example, I would stop that instance. And then this is actually the key command to enable enhanced networking. I use the modify instance attribute command to enable enhanced networking, which is the attribute is specifically is SRIOV net support. And it's important to note that this is sort of a one-way command. This once enhanced networking is turned on, it is on. It's not a command that can be. It's not a capability that can be turned off. I then restart this instance, or rather start this instance. And now when I run the describe instance attribute API, I'll see the output showing SRIOV net support is simple, which confirms that EC2 is providing the virtual function to this instance for enhanced networking. Okay, I'm now going to talk about VPC endpoints for Amazon S3. Again, this was a feature that was launched just over a week ago, and we're pretty excited to get customer feedback on this feature. So endpoints for Amazon S3 was designed to be a highly reliable capability, and it's again designed for the largest workloads. And the key capabilities, there's probably two key capabilities of this feature. One is that it allows customers to use Amazon S3 for object storage without needing to have either an internet gateway or a NAT instance in the VPC. So this allows access to S3 using the private IP addresses of your instances. Instances do not require a public IP address, and you don't need to have a NAT instance in the VPC to use S3. And again, it was designed for the largest workload. So this is a feature that we built for applications that require a high volume of traffic to and from Amazon S3. Additionally, in this feature, we provided additional security controls that allow you to control access to S3 and through the endpoint, which I'll explain in a few moments. So this is a basic picture of how this connectivity looks. So in this case, I have an instance on the left-hand side. I then have my VPC router, which we've talked about a bit. And I configure a VPC endpoint in my VPC, which again logically sort of sits at the boundary of my VPC. But the endpoint provides direct access to Amazon S3. And so, for example, let's assume that I have a bucket in S3, and we'll call it my picks for example purposes. To create an endpoint, I again just use an API command here, or rather a command line command, where I call the create VPC endpoint. I specify the VPC. The third line is the type, and so this is just specifying that it is an S3 endpoint in the same region. That is what is supported. And I configure which routing tables I want to have access to this endpoint. And once that is done, the routing tables are updated to automatically contain, they contain essentially a pointer to S3, to the public IP addresses of S3. But again, even though the routing table will know logically how to route the public addresses of S3, all of the connectivity uses the private IP address of the VPC. So again, VPC instances do not need to have any public IP addresses to use this feature. Additionally, I can specify a policy document. This would be an IAM policy document, and the structure for this document is identical to policy documents that we use throughout AWS. And I'll show a few examples here in a moment. So the way this connectivity works is that an application will resolve the address of the bucket. So in this case, mypicks.s3.amazon AWS. So there's no change to the way applications work to use S3. There's no change to the S3 SDK. The application will resolve it. DNS will respond with the usual IP addresses. So these would be the public IP addresses for Amazon S3. And then my application will initiate a connection again to those public IP addresses. But again, the application and the instance will be using the private IP address to initiate those connections. They'll use the private IP address of the instance to the Amazon S3 public IP address. In the VPC router in the routing table, you'll see that the destination now will be a prefix list. And so this prefix list is a list that refers specifically to Amazon S3. The prefix list is maintained automatically by AWS. So even as Amazon S3 adds additional IP prefixes that correspond with S3 endpoints, no changes are required to your routing table to continue accessing S3 as you do. And in this case, the destination will be the prefix list, and the target will be the VPC endpoint that I just created. Now on the VPC endpoint, I will have the ability to specify an IAM policy, and this policy is specifically to limit the buckets in S3 that can be accessed through the endpoint. So this gives you the ability to put tight controls on the endpoint to only allow access to specific buckets that you control and that you wish for instances to have access to. Now it's important to understand that this will enforce that access, and therefore if the instance requires access to third-party buckets, for example, for software updates or other purposes, the endpoint policy would need to include appropriate access to allow that traffic to those other buckets. And so here's an example of an endpoint policy that would limit the access, or in this case, this would allow access to S3 get object and put object APIs for the MyPix bucket. And this would then implement the policy that I just described on the previous slide. Now, with VPC endpoints for S3, we've also added additional subjects that can be specified in the IAM policy for S3 buckets as well. So in addition to being able to specify an IAM policy on the endpoint itself, you're also now able to specify an IAM, you're able to add capabilities into the bucket policy that will limit access based on whether it's coming from a VPC endpoint or not. And so this would allow you to specify policies, for example, that say requests to store data in this bucket are allowed or permitted only if they're coming from my VPC. So they would have to come from an instance in this VPC. Otherwise, they're denied. And so I'll show an example of the updated S3 bucket policy. And so again, here's an example where I am going to deny access to the MyPix bucket unless the source VPC, the VPC endpoint, is the specified endpoint ID. So I've configured this with the endpoint ID that I'm going to allow access, and everything else to this bucket would be denied. Okay, that concludes my webinar here today on some of the advanced capabilities of virtual private cloud. We will be